So that will make the sender realize that okay, this is the data segment that I need to transmit again. So what do I mean is, for example, let's say here, okay, so let's say here we transmit sequence X. Let's say the window size is 1. I'll tell you what's window size in the next slide. Okay, in the next point. So let's say that the window size is 1. So what is window size is the maximum number of packets that can be transmitted without without acknowledgement from the receiver. For example, what do I mean by the statement is, for example, let's say that the window size is 3. Window size is 3. So what this means is the sender can transmit 3 data segments in one go and then wait for acknowledgement from the receiver. So that is the meaning of window size. So here what will happen is the sender will send 3 data segments to the receiver. Let's say this is the sender and this is the receiver, and it will in one go it will send 3 data segments. Because the window size is 3. The sequence number is 100, then 101 and 102. For example, these are the 3 data segments that the sender sent to the receiver. Now receiver has to acknowledge him all the 3 segments that he has sent. So the acknowledgement number would be sequence number plus 1. So it will be 102 plus 1, 103. So when the sender receives this number that is 103, it comes to know that okay, all my 3 segments have been received by the receiver. Now let's say, for instance, in a case where data segment 103 fails, let's say this fails, 103, 100 is received by the receiver, 101 is not received, 102 is received. Then what will be the acknowledgement number that will be sent by the receiver? So in this case, what receiver will do is it will send acknowledgement number exactly for this sequence number, that is 101. So it will send 101 in the acknowledgement number, which is nothing but a duplicate basically. So this will make the sender understand that I need to retransmit only this 101 again and not 100 and 102. So in the next transmission, when 101, 102, 3, 4 and 5 needs to be transmitted, so it will transmit 101 and then it will transmit 103 and then lastly 104. So this is how we achieve the retransmission of 101 here. This is the retransmission of 101. Retransmitted. Next are 102, 103 and 104, which are the next data segments. So this is how the retransmission works in TCP. Lastly, error-free data transfer. So what this means is that TCP header has something called as checksum, error checksum. In the TCP header, that error checksum field is used to identify bits in error, and that can be corrected or maybe asked again to be retransmitted by the sender. And flow control, this is what we discussed just now. the sliding window technique. So in this technique, what happens is, initially the sender will send will a negotiation will happen between the sender and the receiver for a fit window size that is nothing but will satisfy the buffer size of the receiver. So initially, for example, let's say sender sends window size of 1, data with the window size of 1. Window size is 1. So window size 1 means one packet, one sequence, data sequence segment transmitter. I have to receive one acknowledgement, otherwise I will not transmit next. So that's the meaning of window size 1. So for example, if receiver is okay with that, it will immediately send acknowledgement with whatever sequence number plus 1. Acknowledgement number will be equal to sequence number plus 1. Now the sender knows that this window size is comfortable to the receiver, so I should increase it by 1. So next the sender will increase the window size to 2. So this way the sender will go on increasing the window size to 3, 4, 5 and up to XYZ till when the receiver's buffer fails and it cannot acknowledge the sender, or it tells the sender to stop transmitting. So till then the sender will go on increasing the window size and the receiver will go on acknowledgement. At the point where the acknowledgement fails, the sender knows that okay, this is the window size that the receiver is capable of taking. So now I will use, for example, say window size 10. So then that's what the negotiation is complete between the two. Lastly, congestion control. So whenever the receiver's buffer is full, in case of a TCP transmission, whenever the receiver's buffer is full, the receiver can notify the sender via TCP message that please stop transmission, my buffer is full. Let me process it, I'll tell you again. Then the sender stops the transmission and receiver will again ask the sender to resume the transmission upon the processing of the segments. So this is how the these are the three phases of the TCP operation: the connection establishment, the data transfer, and the connection termination. Now let's take a view of all these states in a single diagram. So this is the TCP state machine. In this state, let me explain the state machine. Okay. So this diagram starts from here, from this point. The first thing which is shown in the diagram is that we are sending a SYN. We are sending a SYN to the other end. Then we are going to the SYN send state. Next, okay. Next, we are sending a SYNAC. And in the third step, the client is sending acknowledgement back to the server. So this is what we discussed in the first part. Let me show you. So this is SYN from client, then SYNAC, and then ACK. So here in this diagram, the message that is written on the right side, that is connect/SYN. So this is sent by us. So first SYN is sent by us. First SYN is sent by us with sequence number XYZ whatever. Second, SYNAC will be sent by the server. So here we can see, yes, the SYNAC will be sent by the server, and at third step, the acknowledgement will be sent by the client. This is the third step, the acknowledgement that is sent, and the TCP session is established at this point. Okay. So at the lower part of the state machine, whatever we have, this is for the termination phase. We'll get into that as well.